Good morning, class. Uh, it's a little late, so I'm going to try to get through this as quickly as I can for my sanity. You don't care one way or another, I'm sure. All right, here we go. Projectile motion. I sort of threw it at you last week, and I let you struggle with it. Good news, I'm going to give you a little bit more information today. Bad news, you're still going to be really confused and going to struggle. That's sort of the point. I know that it's uncomfortable, but you'll actually learn better if you do it this way. If you struggle through it, if you get frustrated and angry, and then it clicks, I promise you that it will make more sense, and more importantly, you will remember it better later. All right, so enough on that. Today we're just going to talk about one type of projectile motion, the type that you're seeing on the screen. When you launch something from ground level, it goes up to a maximum, and it comes down and hits the ground. What do we currently know about projectile motion like this? Well, we know that at that green dot in the middle, at its highest point, the x displacement is going to be roughly half the total. The y displacement is going to be maximized. The time is going to be half the total time, the air time. I also know the velocity in the y direction is going to be 0, and the velocity in the x direction should be constant the entire way. By the time I get over here, all right, well, my y displacement is 0, my x displacement is maximized, my y velocity is the same as the initial y velocity, and my x velocity is the same that it was because it never changed. All right, now, I'm also going to introduce you to a big vocab word today, and that is derive. When the AP uses the word derive, they'll do it in a free response question. And what they mean is, hey, I want you to solve this problem without any numbers. And more than that, I want you to show all your work. And more than that, I want you to start your work with stuff on the equation sheet. So that's what I'm going to be doing today. I'm going to derive the answers to the questions today, to give you an idea of what the AP will be expecting of you and me on your upcoming test. I'll say that again, on your upcoming test. You have a test coming soon, date to be announced shortly, but it is on the horizon. All right. So, some vector stuff on top of what we've already spoken about. I know that the x velocity, the y velocity, theta, and the net velocity are going to be related via this lovely triangle right here. And I know that as the projectile goes through its trajectory, its path, it's going to look something like this, and the vectors at each point would break down something like this. Notice here how there's no triangle. That's because there is no y velocity. It is 0 at that point. I also know the acceleration in the y direction is negative 9.8 meters per second squared. The AP uses negative 10. More specifically, the AP uses g equals positive 10 meters per second squared. So when you're using an acceleration in a case like this, your acceleration is not going to be equal to g. Your acceleration will be equal to negative g. Because it's not positive 10, it's negative 10. Negative meaning down. All right, let's hop right into it. Let's say that I've given you a problem and I say, hey, so I'm launching something from ground level. It is going to hit the ground, which is level, some distance away. I want to know the maximum height my projectile reaches, and I want to know the maximum range. In other words, where does my cannonball, or whatever it is, land? And that's all I'm going to tell you. I'm going to tell you the launch angle. I'm going to call it V0. And I'm going to give you the launch, sorry, that was the launch speed, wasn't it? The launch speed, which is V0, and the launch angle, which is theta. And with those two pieces of information, we can literally find out everything else about this trajectory. Problem-solving technique here. I'm going to separate this into y direction and x direction because it makes it easier. I am not going to try to solve this problem as one big clump because it doesn't work. You have to break it up into just x direction and just y direction. Otherwise, it does not work at all. You're seeing more of my bookshelf than me, so move that a little bit. Oh god, it's falling. All right, so the very first thing that I need to do is I need to figure out, and that's a little better, what do I already know about the y direction? Well, via my triangle, I know that the initial velocity in the y direction is going to be equal to v naught sine theta. I know that my acceleration in the y direction is going to be negative g. And I know that my velocity at the very, very top of my trajectory is going to be 0. That will always be true. Okay. And I want to solve for the max height and range. Well, range has nothing to do with y, so I'm going to ignore that. I'm going to focus on height. All right. I have initial velocity. I have a final velocity, v top. And I have acceleration. I need something that has displacement in it. I need something with a y in it. So I'm going to look at my kinematic equations. And there's only one equation that has v naught, v final, acceleration, and position. Oh, yeah, keeping in mind that triangle. Yeah, it's that one. So I have to start with that one. And I'm going to physically write it out on my paper so that my grader knows what I'm starting from. All right, from there, now I'm going to start plugging in values that I know. For instance, I know that v top is 0, so 0 squared is still 0. I know that v naught y is v naught sine theta. Notice that all of that is squared. I know that acceleration is negative g, so it goes from positive, or goes from plus 2a delta y to negative 2g delta y. But I know that y initial is 0, being the ground, so I'm really just left with y, which, to remind myself, I'm going to label y max. In other words, the maximum height. All right, cool. 0, that's a number I know. V naught, that's a number that I know. Theta, that's a number I know. 2, that's a number I know. G, that's a number I know. Y max, that's a number I need to solve for. Max height. So it's time to do my algebra magic. I'm going to add 2gy to both sides. And then I'm going to divide 2g. There we go. I now have an algebraic solution for maximum height. All right. There's more stuff I can solve for. Because now I know velocity, acceleration, position. So now I can solve for time. So I'm going to slap that up there. Look at this. I'm going to use this easy equation. Bam! I know v top, I know v naught y, I know acceleration. I can solve for the time, which is going to be the time when the velocity is 0. In other words, at the top. In other words, halfway through my trajectory. Half time. All right, so I can solve for half time. Done. Which means I can double it to get air time, because that's the relationship between air time and half time. All right, here is the magic. X direction is impossible to solve unless you have the air time, which is why I started with y. Because now that I know the air time and I know the initial velocity in the x direction, again, because of that triangle, and I know that the acceleration in the x direction is 0, I can use this equation to solve for x. In other words, how far the cannonball lands away from my cannon. Because x naught, 0. Acceleration is 0, so those terms disappear, leaving me with this. That's it. I'm done. I just plug in what I know. And then if I wanted to, I could simplify and make it 3D. But at this point, I'm done. I have solved this problem algebraically. All right. So using these 1, 2, 3, 4, 5 pieces of given information or figured out information, I've solved for these 4 pieces of information: the max height, the time when it's at the max height, the max range, and the time at the max range. In other words, how long it's in the air. And I'm done. Okay, I'm about to give you a headache-inducing physics problem. Do your best. Given range, r, and max height, h, work backwards. I want you to solve for v naught and theta. All right, the rest of this video is just me going to be showing you the answers. It's not for you to watch until after you solve everything. Here we go. Bam, 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 bam. Done. All right. Get to work. Hand it in.